All right, we're going to be looking at the topic of continuity. Doesn't look like that's what that spells, but it does. That's continuity. What we're going to do is we're going to look at a few graphs to help us answer the questions of continuity. Are these graphs continuous? If not, we're going to explain why, or show why, or give notation why. Okay, so let's look at our first graph. Informally, can we draw these graphs without lifting our pencil? Just some arbitrary function here I'm drawing. The removable discontinuity, also known as a point discontinuity, also known as a hole. I'm going to indicate the x-coordinate of that point discontinuity by a C. Okay, so could I draw this graph without lifting my pencil? No, it's not continuous. Why is it not continuous? In order for this graph to be continuous, there has to be a functional value at C. So we're going to say no. The functional value at C must exist. So through graphs, we're going to help us understand the three-part continuity test. Okay, let's look at a different situation. Just a quick sketch, ends in an open circle. Now I'm going to jump up here. I could have jumped down below and then draw off of that point right there. The x-coordinate of that jump discontinuity is C. Is this graph continuous? Can I draw this graph without lifting my pencil? No. Why? It's not continuous because the left limit doesn't equal the right limit. We have a jump discontinuity. Okay, so this graph is not continuous. It has to be true that the left limit equals the right limit. So let's look at that notation. In other words, if the left limit equals the right limit, that is, we're saying that the limit exists. In order for us to have continuity, the limit has to exist as well as I approach C. All right, let's look at the third graph. Very similar to the first graph, except for now, I do have a functional value at C. In example 1 up here, the function was not defined at f of C, at C, so f of C does not exist. Here, f of C does exist, and it's whatever this y value is here. Okay, but still the question remains, is this graph continuous? No. Okay, why not? Because what must be true in order for it to be continuous? Well, in this graph, to make it continuous, the functional value at C, whatever this y value is, must equal the limit as x approaches C. So we've had a little look at this earlier in our year. Now we're visiting it more formally now. The y value right here simply needs to be translated, moved to this point discontinuity for this graph to be continuous. Okay, so that just means that f of C, the y value, must equal the value of the limit. That would just bring these two together and make it so you could draw the graph without lifting your pencil. So informally, a look at the three-part continuity test. Okay, so down here, you might want to continue right underneath here. I think I need to turn the page just to get some more working space. Okay, so if you want to pause the video or all right, here's a definition of continuity. A function f is continuous at x equals c if the following three conditions are met. As we saw in our three examples graphs, the first thing that has to be true is that the function must exist at that particular c value. If there's not a point there, we have trouble. Okay, well, what else has to be true? Well, the limit has to exist. Okay, meaning that we want to avoid vertical asymptotes, jump discontinuities. And remember what this statement is saying right here. This statement is saying that if the limit exists, that implies that the limit from the left and the limit from the right are equal. In the third condition, it's not enough that the function exists. It's not enough by itself that the limit exists. It has to be true that that functional value, okay, is actually equal to the limit, which in fact just says that number 1 must be equal to number 2. And that's it. That's a 3-part continuity test. So in the next video, what we're going to look at is some specific examples on a graph of how to verify, prove that that we have continuity or we don't. So I'll see you soon.